Trapezoids. In review, quadrilaterals have four sides. Parallelograms. What is true about a parallelogram? First, what makes it a parallelogram? Opposite sides are what? Parallel. That's what makes it a parallelogram. Two, opposite sides are now congruent. Opposite angles are congruent. Consecutive angles supplementary. I don't expect you as much to be able to read this, but we've already written this down, haven't we? So you ought to, hopefully by heart, you almost ought to have this. Diagonals bisect each other. Last thing, one diagonal makes two congruent triangles. Trying to paraphrase as much as possible. Now, we learned about different types of parallelograms. Over here to the left, the next one we learned about was called a what? Rectangle. And then we had a what? What makes something a rectangle? Nope. All four angles are 90 degrees. That's what makes something a rectangle. Other facts true about a rectangle. Diagonals are what? Congruent. Was there anything else? I don't think there was. Things that are true about a rhombus. What makes it a rhombus? All four sides are what? Congruent. Diagonals bisect each vertex angle. Diagonals are perpendicular. Is that everything? Does anybody have those notes from the other day and check so we can check ourselves? Rectangle rhombus had a kid. What would they call it?
Square.
What makes something a square? All four sides are congruent and all four angles are 90 degrees. That is this chapter in a nutshell, isn't it? But for the most part, what type of quadrilateral have we been talking about? Hmm. Did somebody say it? No, we've been talking about parallelograms. Exactly right. What have we not? So all we've talked about are types of parallelograms, correct? Well, now we're going to talk about something that's not a parallelogram. So as you can see, I've left space off there to the right, haven't I? Would you agree? Well, the reason I have is because we're going to talk about a type of quadrilateral that is not a what? All of these are what? Parallelograms. Now I'm going to talk about something called a trapezoid. Each time when I do these type of lists, what have I said to the first one? Number one. When I said parallelogram, what did I ask you guys? I said what? What makes it a parallelogram? When I say that, that's the definition of it, correct? You know, when you look up parallelogram in the back of the book, it's going to say a quadrilateral where the opposite sides are what? Parallel. Okay? Each time, what makes something a rectangle? A quadrilateral where all the vertex angles are 90 degrees. You know, rhombus, a quadrilateral where all four sides are what? Congruent. That's what makes it a rhombus. The first thing is always basically the definition. Down to the square. What makes something a square? All four sides congruent and all angles are what? 90 degrees. Both of those have to be true for it to be a square. Now, what makes something a trapezoid? It has exactly one set of parallel sides. And the key word here is exactly one set. What makes something a parallelogram? It has how many sets of parallel sides? Two. Trapezoid has exactly one. In other words, the other two, if it's a trapezoid, they cannot be parallel. So how would you draw that? Well, I'll draw two parallel sides real easy here. You know, these ought to be parallel, shouldn't they? Because I kind of traced it right there. Would you guys agree that this is parallel to this? Now here's the thing. If I'd have made these the same length, if I'd have made, you know, this one the same length as that one, would these two have been parallel too? They would have, wouldn't they? So a key thing about a trapezoid is that these two sides, which we're going to name them here in a second, are always different length. Because if they're the same length, then you're going to have a parallelogram on your hand. In a trapezoid, these two sides here, this is called a base. This is called a what? Base. There are two bases. The sides that connect the two bases, they're called the leg. So there are two legs and two bases. These angles right here and right here, these are called base angles. I guess I can zoom in more since we're not concerned with the left side here. Those are called base angles. Didn't do a real good job of pointing at it. This is a base angle, but guess what, guys? There's another set of base angles. It's right there and right there. That's another set of what? Base angles. This is a set. This is the base angles that go with the bottom base. Think of it like that, because it's connected to this bottom base, right? This is the what? One connected to the what? Top base. It's important to think of them separately for how they're going to define an isosceles trapezoid. What else do you think you can say about a trapezoid? In fact, I shouldn't have drawn that arrow. So don't draw that arrow. See if I can find some white out here. Maybe too cold. Okay. Draw yourself another picture of a trapezoid. Label it A, B, C, D. When you're trying to figure out what's the base, what's the legs, always find the two sides that are what? Parallel. What do you think you can tell me about angle A and angle B in a trapezoid? Here's how I'm going to say this for two. This is always true about a trapezoid. Opposite base angles are supplementary. What does that mean? They add to 180 degrees. Now, what do you think I mean by opposite base angles? What did I tell you? Angle A and angle D are one set of base angles, right? Angle B and angle C are another one. Which ones do you think add when I say opposite? I don't mean the base angles that go with each other. I mean the ones what? Opposite each other. Or, so, maybe I shouldn't say opposite. The race opposite. Let's say, because opposite's going to make you think to go to there. So we'll go with consecutive base angles are supplementary.
So A and B add to
These add to 180. What about these two?
180.
Can anybody tell me why those two would not add to 180?
Oh, because they're not consecutive.
They're the, you think of these as one set, right? Consecutive base angles, in other words, ones from a different set, they add to 180. The ones beside each other don't. And here's the other reason. Does anybody know why these two add to 180?
Because they're different bases.
Nope, I actually just gave you a hint by what I was drawing up there.
The lines are parallel.
These two lines are parallel, and isn't that right there, two parallel lines being cut by a transversal? Isn't the ones right on top of each other always add to what? 180? Isn't that what that is? Isn't that what that is? That's why. Okay? Now, last thing to talk about spell that wrong?
I don't know that you did spell trapezoid wrong.
I always do that. It's a habit.
You can read. It's too busy rolling joints.
Quiet, please. That's not even funny.
Oh, is it playing? Oh, okay, let's talk.
Isosceles trapezoid. Okay, so with this one, everything that's true up here is true. What makes something an isosceles trapezoid? The legs are congruent. So if I was to draw a picture of that, which one of the legs here?
A, D, C.
So AD is congruent to what? Okay? No, that's the only legs there is. The other things that are true about it, base angles are congruent. Now, am I talking about the ones on top of each other?
Nope.
No, they add to 180. I'm talking about these. Angle D is congruent. What base angle goes with it?
C.
Angle A is congruent to what? Okay.
Easy peasy.
No.
You get this?
Now on a separate sheet of paper, we need to talk about the median of a trapezoid.
Do it on the separate.
Or just somewhere else on your notes. Come on, go sit in the hall. Just go. You need anything else but yourself. Leave the door open so you can hear. Now, you notice this is not a isosceles, it's not any kind of special trapezoid. We're just going to talk about the median of a trapezoid. Do you remember what the median of a triangle was? Evidently not. The median of a triangle was basically, if you found the midpoint of this side, looks to me like it's between 6 and 4, so right at 5 would be the midpoint. Correct? Length of this one What did I just meet there? What did I measure off?
The middle of both lines.
The middle of both lines, the midpoint. Medians connect midpoints of sides. So that means that this is congruent to this, and what? This is congruent to that. That's what makes it a median. Make this point E, and make that point F. E and F are what?
Parallel.
Midpoints. They're points. They can't be parallel. E and F are midpoints. There's an interesting thing that happens. First of all, I know that this is parallel to this, correct? It turns out, what do you think EF is? First thing that happens, well, we know that BC is parallel to what? AD, right? Because that's what makes it a trapezoid. What do you think this median is?
Parallel to both sides.
It's parallel to both of those too, isn't it? So the median is parallel to both bases. That's kind of an obvious thing, but here's the thing, the reason there's even a theorem about this. The length of the median will always be half the sum of the bases. I want you guys to see if you could write that out as an equation with this picture. The length of the median is always equal to half the sum of the bases. And if you need sum of the length of the basis, if that doesn't make sense to you. When I say sum of the bases, I'm talking about the length of the bases. So basically, you add those two lengths up, divide it by 2, you get that, don't you? Isn't that what that says? So how could I write that in a geometry equation? How do I represent the length of the median in this picture? What is the median? EF. Well, I represented the segment by putting EF and putting a line over. How do I represent the distance? By not putting a... So what I would say here is that EF, when I just write that, is equal to, I'm talking about the distance from E to what? Leave me alone.
I was wondering, do you want me to open the door if there's like...
Sure. EF is equal to the sum of the bases. How would I write that? You want to say AD is the length of that base, right? Plus what? BC. Is everybody okay with that? But I've got to take that, and then what do I do next?
Divided by 2,
So how do I need to write this?
put it over 2.
Do I just put the BC over 2? I could put the whole thing over what? Does that say what we need? That's how it works, isn't it? Now in the book it would be written like this. Is this not the same thing? Is that not the same thing? But doesn't, in a way, isn't that what you're going to kind of do in your mind? You're going to add this and then press divide by what? So if this was 5 and this was 11, what would the length of this be? I would say 5 plus what? 11 divided by what? Which is equal to? That's what the length of that would be. Since the notes have kind of gone longer than expected, worksheet the first of the hour.